So this was a pop quiz related to mass spectrometer and the bonding topic. So in the first question, this question is about the mass spectrometry and the shapes of the molecules. In a mass spectrometer, vaporized atoms are ionized and the ions are formed. The ions formed are accelerated, deflected, and detected. State how atoms are ionized in a mass spectrometer. So how we ionize the atoms in the mass spectrometer. So what we simply do, the sample is subjected to like bombarding or spiking with a high energy electrons. So by striking the sample with high energy electron, which will remove the electrons from the sample and form positive ion. So when a positive ion is formed by knocking out the electron, and it is irrespective of, we can have a metal or a non-metal, but when we subject it to like excel hitting the sample with a high energy electrons, we knock out the electron from the sample and it will produce a positive ion, or a cation will be produced, or the whole molecule will have a positive molecular ion will be there. Explain why isotopes of an element have the same chemical properties, but their ions are deflected differently in the mass spectrometer. So the chemical properties, basically, the chemical properties depends on the electronic configuration. So because they have atoms or isotopes, because they have the same electronic configuration, that's why they have the same chemical properties. Where in a mass, the deflection depends on mass to charge ratio. Because they have different mass to charge ratio, that's why they deflected differently. So the chemical properties you can write here depends on the electronic structure or number of electrons in the last shell. So atoms or isotopes have same number of electron in the last shell. Where the deflection in the mass spectrometer depends on the mass to charge ratio. M by E or M by Z, actually it's usually M by Z, which is a mass to charge ratio, because they have different mass to charge ratio. So as they have different masses, so different M by Z ratio, and the isotope with smaller M by Z ratio will deflect more, or there will be a large deflection. So the one with a smaller mass to charge ratio, it will show a greater change in direction as compared to one with a large mass to charge ratio. In part B, the data from mass spectra may be used to determine the relative atomic mass of an element. What is meant by the relative atomic mass? This is a standard definition you have to learn for a relative atomic mass. Relative atomic mass is actually an average mass of an atom, or average mass of an element, which is compared with the 12th part of carbon 12. So one mark is for average mass of an atom, or element, and the second mark, which is compared with the 12th part of carbon 12. Because carbon can also have an isotope carbon 12 and 14. So when we compare how many pieces of carbon 12 are needed to balance that atom, that is known as its relative atomic mass, also known as RAM. A sample of a chlorine contains 73.53% chlorine, 24.47% chlorine 37 and 35 are there. So how to work out the average mass, average relative atomic mass of the isotopes? So percentage of the isotope, which is 75.53, multiplied by mass of the isotope 35, percentage of the isotope 24.47 multiplied by mass, which is 37, and divided by the sum of the percentage, which is 100 here. That will give us a relative atomic mass, average mass of the two isotopes. And you have to write your answer to four significant figure. So that will be 35.49. The next part, the mass spectrum of a phosphorus trichloride, it's a molecule like phosphorus trichloride. There we were having an element molecule, but here it's a compound, phosphorus trichloride, and it has only phosphorus 31 is there. And there are three peaks in the region of 101 to 105. Complete the table to show ions which are responsible, and the mass of a phosphorus is given. A phosphorus chloride is given, and which is PCl3. And out of this PCl3, we have phosphorus 31, which is a fix. And we have the two isotopes of the chlorine. What are the two isotopes? It might be 35, chlorine 35, or it may be 37. We want to identify like which ions for 101, 103, and 105 are responsible for the peaks in a mass spectrum. So if we work out the total mass of this compound, so here what we have phosphorus, which is 31. And it might be 37, but if we work out the maximum mass, like the example, we consider all of the three chlorine are 37. So we have 37 multiplied by 3 plus 35, which is 146. So the molecular mass, like the whole molecule, maximum mass of this molecule should be 146. But we want to work out phosphor 101. So what might be like if we get the whole molecule and with a maximum, all of them are 37 chlorine and one is phosphorus. So the total mass or the molecular mass of that will be 146. But we have 101. So it means it's not like it cannot be PCl3. It should be another molecule. So how it might break down? It might be PCl2 plus and Cl radical. So what will the mass of PCl2 if we work out the maximum mass? So it might be phosphorus 31 and chlorine is 37 and 37 if I work out the maximum mass. So 37 plus 37 plus 35, or you can say 37 multiplied by 2 plus 31, that will make 105. So means this molecule might be PCl2, like it might be PCl2, which contain phosphorus 31. It might contain chlorine 37, or it may contain another chlorine 37. So one phosphorus and two chlorine, and both of the chlorine atoms are 37. But what if we have one of them is 37 and another one is 35? So in this case, the mass will be 103, because when you sum them, so it will be phosphorus 31, chlorine 35, and chlorine 37. And what if we have all of them are like both chlorine are 31, 35 So 31 plus 35 plus 35. So it will be 101. So it might be chlorine 31, chlorine 35, chlorine 35. And don't forget to write the charge, a plus charge. It's very important that you write a charge, as it shows that because you cannot detect the radicals, you can only detect the ions. So, and that's why it's important that you write the charge. If you just write this, like you wrote phosphorus 31, chlorine 35, and chlorine 35, but you did not write the charge in exam, it's considered as wrong. Why? Because this cannot be detected in the mass spectrometer. In a mass spectrometer, we can only detect the ions. So it's important, whenever they ask what is detected in the mass spectrometer, you have to write the charge on them. Then we have to show that the relative peak height is given in the table is consistent with the ratio of chlorine 35 to 37, which is 3:1. Look how we can work out. As we know, we have like chlorine 35 and chlorine 37. When we use a ratio of their percentages in the beginning of the question, the ratio of the percentage 75.53 and 24. So if we divide, it will be 3:1. Like if we divide both of them by 24.47, this chlorine 35 will be 3. So chlorine 35 will be 3 parts. If we have total 4 parts, so 3 parts will be chlorine 35 and 1 part will be chlorine 37. So how the table is consistent with the isotopic ratios? As you can see here, the peak height is 9, 6, and 1. So how we can show that this peak height is 9, 6, and 1? So same idea. If we were having, like in phosphorus, if we were having both of them as chlorine 35, or one of them is chlorine 35 and one is chlorine 37. Or we may have both of them as chlorine 37. So what will the ratio, because this is 3 is to 4 and 1 is to 4. So what will the total ratio when we multiply? It will be 9 by 16 because, 3 by 16 because it is 3 multiplied by 1. So this whole will be 3 by 16. This when we multiply, chlorine 35 is 3 by 4. If we have both of them are chlorine 35, so 3 by 4 and 3 by 4, so this will be 9 by 16. And this is 1 by 4 and this is also 1 by 4, so this will be 1 by 16. So what is the simplest ratio between them? 16 is a denominator for all of them. So if we have both of the, like one is chlorine 35, one is chlorine 37, this will be 3 times. If we have 3 by 4 and 3 by, like, so it will be 9 times and this will be 1. Same way, because in the question, how the data is consistent, as we work out, we said this was having both of them chlorine 35. This was having both of them either 35 or 37. And this was having both of them 37 and 37, along with the phosphorus, which is 31. So this is 1 by 4, 3 by 4, multiply by 3 by 4. So we get 9. This what might happen, like maybe the first is 35, other is 37, or it can be other way around. It can be 37 and 35. So this will be 1 by 4 into 35. So this is 3 by 4 and this is 1 by 4, which is equals to 3 by 16. But this 3 by 16 for one type. But what we may have a phosphorus, and first one is chlorine 37 and the other one is chlorine 35. So we also have another fraction which is 1 by 4 and 3 by 4. So the total will be 3 by 16. So when we sum them, we will get 6 by 16. 6 by 16. So this will be 6 by 16. This will be 9 by 16. And this is 1 by 4 and into 1 by 4. So we get 1 by 16. So when we take a simplest ratio, it will be 9, 6, and 1. Why this one is coming out 6? Because two possibilities are there that maybe the two chlorine attach. First chlorine is 35, other chlorine is 37, or maybe the first chlorine is 37 and the other chlorine is 35. So as a result, what we'll get like this peak will be twice. That's why the ratio for this one is 3 by 16. Ratio for this one is 3 by 16. So what will the sum of their ratios? So it will be 6 by 16. Is it clear, this one? How we worked out the ratios of the peaks? Any doubt in this part two? Any doubt in this? Okay. Draw dot and cross diagram for the PCl3 molecule. So phosphorus belongs to group 5 and chlorine belongs to group 7. So chlorine share 1, phosphorus will share 1 from that side. And chlorine share 1, phosphorus share 1, and 2 unshared. Then predicting the shape, how we can predict the shape? How many bond pairs are there? 1 bond pair, 2 bond pair, 3 bond pair. So there are 3 bond pairs. And there is 1 lone pair. And total, how many pairs are there? There are 4 electron pairs. Out of 4, 3 of them are bond pairs and 1 is the lone pair. So when we have 3 bond pairs or a shared pair and 1 lone, total are 4, 3 bond pair, 1 lone pair. So according to like the electrons will try to minimize the repulsion, and when they minimize the repulsion between the bond pair is less than compared to lone pair and bond pair, and the structure will be trigonal pyramidal. So this structure, like phosphorus will be there, one will be into the plane, one will be out of the plane, and one is in the same plane with a bond angle of 107. The bond pair repulsion is less than the lone pair repulsion, and as we have 3 bond pair and 1 lone pair, so they will minimize the repulsion and arrange them in a geometry or a structure which will be a trigonal pyramidal. So you have to mention the structure as well. So it will be trigonal. Trigonal is optional, but pyramidal shape you have to mention. So this was the pop quiz 27.